So I hope you had your coffee. Yes, it's free. And lovely. I have a question to you. How many of you are using open tracing? Okay, you're totally screwed. Yes, because nobody uses open tracing anymore. It's dead. And the OpenTelemetry is the king now. And I'm quite happy that our great friend, Nicolas Fränkel.
But it's written with an S because...
Yes, because it's ridiculous French language.
Yeah.
Yes. Yes, they put additional S's everywhere. Yes, so our good friend Nicolas Fränkel, who is actually speaking, how many languages do you speak? 7, 6, 11, 24?
4 or 5, depending on who you ask.
Yeah, and are we cursing or not? Yes. Yes, our great friend Nicolas Fränkel is here, and I'm really happy that he was going to give us to talk about the technology that we have to use in production because it's the king, and it's OpenTelemetry, and we really need it in production. So, warm welcome, Nicolas. Hello.
Dobre jutro, Sofia. Thanks to be here. I'm Nicolas Fränkel. I've been working for more than a couple of years in IT. I have experience, or trouble, depending on who you ask. I've been working both in the development side and in the developer advocacy side. So as I mentioned, I have quite a bit of experience, and when I started my job in IT, we didn't talk about observability, we talked about monitoring. And at the time, monitoring were a bunch of people sitting in front of a giant screen, well, much smaller than that at the time, and they were looking at dashboards all day. And if a dashboard looked like bad, then they would log into the machine and start to understand what was happening by reading the logs. But unfortunately, it doesn't work like this anymore, because our systems are becoming more and more distributed. I'm not using the word microservices on purpose, because if you do microservices, probably you are doing it wrong. But there is no denying that the systems are becoming more and more distributed. So we invented a new term called observability. The idea of observability is you detect the problem before it happens. That's the idea, which is a good idea. I'm a big fan of Wikipedia definition, so I copy-paste them a lot. I let you read it. And this one is lacking, because they mention distributed system, which is a good thing, but they mention logging and tracing, and observability is built on 3 pillars, not 2. They forgot metrics. This talk is mainly about distributed tracing, but I have a couple of slides on metrics and logging as well. First, metrics. I believe everybody does metrics already. Who doesn't do metric? Who doesn't track any metrics in their system? Good. The only advice I can give you is most of the time we have been lost in time and we still track system metrics, which are useful, but not that much. Like if you tell the business that your CPU is used 50% or that your disk is 80% full, they don't care. So probably you should use the same underlying infrastructure to give them higher level metrics, metrics that talk to them. The number of orders in the last hour if you are doing e-commerce, the number of, I don't know, 500 errors that happened, the number of 404 or whatever. So just give them higher level and you will get something in return that's called budget, which is very good. Logging. Logging is another beast. At one point I had a whole talk dedicated to logging, because a lot of people do logging wrong. The first thing is what to log. When I was a young Java engineer, I realized that some developers did logging pretty nicely, and some developers didn't, or didn't do at all. And so that's a problem. How can I solve it? I'm smart. I will create a Java agent, or something that will change the code at runtime to actually log every input parameter and every return value. And this way, then I will have a complete logging for every function, every method in my applications. And the developers, whether they are good or bad, I don't care. Everything will be done for them. And then I forgot that some stuff can't be logged, and there are still input parameters, such as passwords, for example. So there is no magic solution in that. You need to be careful about logging. You need to take care about logging as much as you do when you do code reviews. Oh, you know, you didn't apply this proper principle, or this one can be simplified. You should do the exact same for logging. Here you have like 100 lines method. Of course, it should be separated into different methods if they can, but you should add logging statements to understand what's happening. Second problem. I mentioned at the time we were actually logging to the machine and reading the logs to understand what's happening to solve a problem. But nowadays, you can't do that. The first thing is you don't know which machine to log into, because, again, distributed system. Second problem, you probably are using containers. And containers, they come and they go. So the machine that produced the log might be long gone. So you are not logging to the machine. What you are doing is you are pushing all the logs from all the machine to a centralized logging system. And in order to push it, you need the log to be structured. And most of the time, the logs are not structured. So you have an additional component in your architecture that actually groks the line. This is the level, this is a timestamp, this is a thread, and this is the log message, and makes it a JSON out of it. This component is fragile, takes time and resources, and doesn't bring anything to the table. Why don't you produce your log in JSON already? Who is already outputting JSON logs? Good. I saw somebody very enthusiastic. 2, 3, 4. Well, you are not so enthusiastic. Okay, a couple. Tomorrow, no, tomorrow is the conference, but on Friday, that's the first thing you should do. You talk to your ops guy, or if you are the ops person here, you do it yourself. You ask your developer to produce JSON output, and you remove this extra component that is actually like unnecessary. When I started to work, I was forbidden to ever log to the console. Everyone was supposed to write logs on files, because then you could actually like rotate the log files and archive them. And nowadays you are using containers. Where do you log? Console. So it changes all the time. If you are an architect, you also need to find the right system. Is it better to push or to pull? There is no right answer. There are benefits, pros and cons in each solution. You need to think about how long you should store the log. If you are working in banking industry, it's not the same as if you are working on Candy Crush. And then you have a system to search and display the logs. Here are a couple of systems. Myself, I know the Elastic Stack better, but whatever rocks your boat. Now comes the most important part, tracing. So again, a very nice definition from Wikipedia, which I prefer mine, to be honest. Basically, yeah, every time you should prefer yours, which is better. Every time you do your own definition of Wikipedia when it's not worth it. But I still like to have the original. Anyway, tracing is the way to trace a business request across a set of components in your infrastructure to understand the flow. Right? It's very easy when you say it. It has been very hard for ages. Why was it so hard? Well, there were a couple of precursors, companies who were interested in that. For example, you might have used Zipkin or Jaeger in the past. And they worked pretty well. The problem is they limited you. How did they limit you? Well, if you choose Zipkin, now you had to choose a library for your application that was Zipkin compatible. All the components in your infrastructure were to be Zipkin compatible. Same stuff for Jaeger or for OpenTracing. And so as an architect, I don't like it, because when I want to choose something, a component, I don't want to limit myself. I want to have as many options as possible to choose the best one. When it happens, in general, you need a standard. And not like in the XKCD comics, where you have 14 standards, and you have a standard to bind them all, and now you have 15 standards. You need a real standard. And in order to have a real standard, you need to have a strong organization to actually create it. And this is what happens. There was a specification called the Trace Context Specification written by the W3C, which is a strong governing body. Who knows about this specification? One hand, okay. I encourage you to read it. It's 20 pages. It's quite easy to read. Even I could read it. And basically, the specification tells about a specific HTTP header, which carries several information, and that is like propagated from component to component through HTTP. And among this information are the two important ones: a trace. So a trace is a single business request that flows across all the components. And a span. And a span is something that happens inside of the component. A span is bound to a trace, which is for sure. A component has at least one span. I mean, something must happen in the components. But multiple spans are also possible. And spans, if there are multiple, are bound by a parent-child relationship, so that a span can have a parent, and a parent can have multiple children. This is the graphical view, and now I must check if it works. Yes, it works. So you have a single trace here, and then you have 3 components, and you have 3 spans, 1 span per component, X, Y, and Z. And Y and Z are children of X. X has no parent, it's the first span. I mean, that's not super high-level engineering, right? It's pretty straightforward. Now comes OpenTelemetry, because you, as developers, could do the HTTP propagation yourself. You can create the header, you can create a new span ID, but we are lazy by nature. I am lazy. I'm a good engineer, right? I'm very, very lazy. And we want stuff to be done for us. And OpenTelemetry comes and say, oh, I will do that for you. I have libraries and SDKs and tools to do that. Make no mistake, OpenTelemetry is much wider than just tracing. It does metrics, it does logs as well, but it does the distributed tracing part. And actually, it's a merge of OpenTracing and OpenCensus. Hence, the comment by Dimitri that you shouldn't use OpenTracing anymore. It has been merged, so if you are using it, you should probably migrate. It's a CNCF-backed project. It's still in the incubator phase. It's Apache v2 license, so open source all the way, and it has more than 5K followers on GitHub, which is a lot. Here is the architecture, which is, again, not very hard. At the center sits something called the OpenTelemetry collector. The OpenTelemetry collector is not mandatory, but it's advised to use it, because all the sources that can create OpenTelemetry data can dump their data into the OpenTelemetry collector. The OpenTelemetry collector defines a format in which it receives OpenTelemetry data. So basically, you can implement your own OpenTelemetry collector. What happens after the OpenTelemetry collector, OpenTelemetry doesn't care. So that's not their problem. So you can push it to your database of choice and make the choices that basically are adequate to you, whether you value long-term storage, whether you value like cost effectiveness, this kind of stuff. The good thing is Jaeger and Zipkin, they offer an OpenTelemetry compatible endpoint. So if you're already using one of them, you can just open the port of OpenTelemetry, and then you can switch your application to send OpenTelemetry data instead of the proprietary Zipkin or Jaeger data. And nothing changes. You will still get the same data in different format. You can store it in the same place. And afterwards, you are in a very nice place because now you are using OpenTelemetry, so you can change your infrastructure for anything that is OpenTelemetry compatible, which is the right benefit. Who here is a developer? Same enthusiasm, I like it. Not that many people, but let's say 2/3 of the room. So this talk was written for developers. I've told about the context. Now I will tell you, as developers, how you should start to do OpenTelemetry. If you are an ops person, who is an ops? Not that enthusiastic. Who is a DevOps? Yeah, whatever that means, right? Nobody cares. You are a DevOps, that's good enough for you. Okay, so if you are an ops or a DevOps, I hope that you can benefit from this talk anyway, so you can tell your dev colleagues to watch it and to tell them to start helping you do your job. So if you are a developer, there are two ways to approach OpenTelemetry. The easy way, which I really recommend. The first is called zero-code instrumentation. So basically, as a developer, you don't do anything. It's a runtime concern. For that, you must have a runtime. It can be either the JVM, or if you are using Python, the Python runtime, or Node.js, or .NET, whatever. So if you have a runtime, you have zero-code instrumentation. Or if you are running on Kubernetes, you also can have zero-code instrumentation. That is very nice. It means your developers are not bothered. They don't need to know anything about OpenTelemetry. They continue to produce their code to implement their business requests. It's basically zero code, meaning zero cost. It's a runtime detail. If you don't have a runtime, if you are using Rust or Go. Sorry, must wash my mouth. You don't have these benefits. So in that case, you need to get the library and do the work yourself. Though most of the frameworks, they do it for you. You just need to copy-paste the right snippet, and they will do it for you through filters or proxy or whatever. This is also the path that you can choose once you've got enough data. Like if the zero-code instrumentation gives you enough data, but you want more control over it, then you can also choose as a JVM developer or .NET developer to use the library yourself. My advice, be lazy. Do the zero-code approach before. Get a server somewhere in the cloud or wherever. Shadow IT. Don't tell anybody about it. Get data. Use the data to solve the problem. And then go to your manager and say, look, I have solved it with OpenTelemetry. Now, can we create a project and have budget? I've worked in companies before. This is a really, really nice way to start. Okay, I've talked a lot, and I believe in the power of demo. I mentioned I'm a developer advocate, and we have this reputation to do hello worlds, like stuff that just works in a very limited context. So I wanted to, yeah, it makes you smile, right? So I wanted something a bit more involved, so this is my hello world for OpenTelemetry. The first, it's an API, and I've worked in e-commerce, so it's supposed to mimic an e-commerce distributed architecture. So first, you have you go through the API gateway, and the API gateway goes to the first component. The first component is a catalog. The catalog is a Kotlin Spring Boot app, and it requires additional data. It requires the state of the stocks and the pricing. So I actually have other components to have the state of the stock. This is a Rust Axiom application, but it just centralizes the warehouses. So I have another warehouse here, also Kotlin and Spring Boot, but this one is in GraalVM. So there is no runtime, so I can't address it the same way. I have Go stuff because it's very popular for whatever reason. I have a Ruby one just for fun. I'm using also Quarkus with regular Java codes. The pricing is in Python and Flask. I have another Python application here, but I will instrument it with Kubernetes just to show you how it can be done. And because I've given this talk a lot of times, and at the beginning, everybody asked me, hey, look, how does it work with asynchronous messages? Because if you are using HTTP, everything is fine, but without HTTP, how does it work with Kafka or with MQ? So I've created an implementation. Here, every time you query the catalog, it publishes some like analytics in MQTT, a broker, and I have a Node.js TypeScript application that subscribes to it and that propagates the context throughout the message queue. Good enough for you? Okay, I won't have the time to describe everything. I will assume that we are in a Java conference because it's called JPrime, right? So I will show you stuff about the JVM and Java, but everything is on GitHub. To deploy it, I will use Kubernetes. So I will use a virtual cluster to like separate between my business app and my infrastructure. In both of my cluster, I will have a collector. So I will dump everything from all the components into this collector. And both collectors will dump their stuff into a Jaeger instance. Shall we start? So I asked the demo gods to be with me. It's always a good thing to do. The first thing that I will actually do is to create the infrastructure, and I will describe the code to you in the meanwhile. So here, I will create the infrastructure where I have it starts very well. I have closed orb stack. Too fast. Okay. Now I will create the Helm chart for the infrastructure. Now I've created a virtual cluster inside the host cluster, so I will connect to the virtual cluster. So here at this point, I can alias k equals kubectl, and I will k get pods all namespaces. So you've got a lot of stuff. And if I connect inside the vCluster, it might take a bit of time until everything is fine. But if I do the same, you will notice that I'm completely independent. And this little idiot takes ages to start. So meanwhile, I will describe to you the code. I will start with the catalog. There is nothing related to OpenTelemetry here. And I can still tell you it will work. Because in the Docker file, so what should be a runtime concern, because I'm using containers, becomes a build time concern. But again, depending who is creating your images, it might not be the problem of the developer. This is a multi-stage Docker file. 2 stages. The first one, I create the jar. So I compile, I create the jar. The second one, I add the OpenTelemetry agent. And then I run it with the OpenTelemetry agent. Yes, it has worked. It was a bit slow. Now I can deploy it. How do you think it works with GraalVM? Because with GraalVM, it compiles to native code. I can't have an agent. Well, with GraalVM, I'm not in the same position. In that case, I need to use how Spring actually does OpenTelemetry. I can't rely on a generic agent. I need to use micrometer tracing, the actuator, the tracing bridge, and the exporter. That being said, everything has been deployed.